So let me start with the module 1 in case of the 8051 microcontroller. So the module 1 title is 8051 microcontroller. So it is a syllabus of the 8051 microcontroller. So here you are going to study regarding the difference between the microprocessor along with the controller, embedded system, embedded microcontroller, 8051 architecture, registers, pin diagram, I/O port functions, internal memory organization along with the external memory interfacing. So it is the syllabus of your first module. So let me start with the definition of the microcontroller. So microcontroller, it is a single integrated circuit which is dedicated to perform and execute only one task. For specific application, you are going to make use of the microcontroller. So microcontroller is a small size device which will have the controlling capacity. This microcontroller, it internally consists of the CPU. Along with that, it has an inbuilt RAM memory, ROM memory, I/O devices, timers and counters. So all those things will be available on a single chip. So this microcontroller, so you can call it as it is a CPU which is available in the form of a chip. And this microcontroller, so we are going to call it as a mini microcomputers. So for your syllabus, you have the 8051 microcontroller. So this 8051 microcontroller, it was introduced by a person called as an Intel in the year 1981. So why it is called as an 8-bit microcontroller means the CPU, it can work at a time only on the 8-bit data. And this 8051 microcontroller, so that we are going to call it as a 8051 microcontroller. The 8051 microcontroller, it is an 8-bit microcontroller and it was introduced by a person called as an Intel in the year 1981. So microcontroller, it is nothing but a small size device which has a computing and processing capability. Next we'll see the difference between the microprocessor and microcontroller. The first difference is the block diagram. So in case of the microprocessor, in the block diagram, it consists of only the CPU, RAM, ROM, I/O port, timer and counters. So those things are separately interfaced to this microprocessor. So in case of the microcontroller, in the block diagram of the microcontroller, we have the CPU unit, RAM unit, ROM unit, I/O devices, timers along with the serial port. So all those things will be available on a single chip. In case of the microprocessor, it has only the CPU. Other units or other devices, they are externally interfaced. So the next difference is the microprocessor, it has many instructions. So in order to move the data between the memory and the CPU. In case of the microcontroller, it has only a few instructions, 1 or 2 instructions to move the data between the memory and the CPU unit. The next difference is the microprocessor will has the 1 or 2 bit handling instructions, whereas the microcontroller will has the many bit handling instructions. Next difference is microprocessor has the single memory. For both the data and the program will be stored using a single memory in case of the microprocessor. In case of the microcontroller, it has a separate memory for the data and the program. The data and the program will be stored in a separate memory. We have the separate memory for storing the data along with that for storing the program or the code. So next is microprocessor will have the large number of instructions set are available, whereas the microcontroller will have the limited number of the instruction set available. Next is the designing of the microprocessor, it is more flexible, whereas the designing of the microcontroller is less flexible. The microprocessor, it requires the high power consumption. The microcontroller requires the less power consumption. The microprocessor, it is more versatile, whereas the microcontroller is less versatile or it is not versatile compared to the microprocessor. The operation of this microprocessor, it is very high speed and also of the high cost, whereas the operation of the microcontroller, it is of the lower speed and the cost is also low. The microprocessor, it is always designed for the general purpose, whereas the microcontroller, it is always designed for the specific purpose. So these are some of the differences between the microprocessor along with the micro. So next is the embedded system. So this embedded system, we are going to define it as it is a combination of the computer hardware along with the software that will do some specific job. So this embedded system, they are mainly used in case of the consumer electronics, food processing industry, in the chemical plants, in the telecommunication field, in the security, in the biomedical equipments, and all those things we are going to make use of this embedded system. So it is a combination of the computer hardware along with the software that will do some specific job. So next is we'll see the characteristics of the embedded system. The first one is reliability. That means the reliability of the hardware and the software, it is most important. So whenever you are going to design any embedded system, and this embedded system should reboot itself without the human intervention during the failure. Whenever there is a failure in the embedded system should reboot itself. So that will result in that is one of the important characteristics of the embedded system. This embedded system should be reliable. The second one is cost effectiveness. So these embedded system, so they are designed in order to meet the requirements of the specific applications in the mass market, and hence by keeping this, the product cost must be reasonable. So that is the second characteristics. The third one is low power consumption. So in order to increase the life of a battery, the power consumption has to be limited. So this you can achieve by reducing the number of the hardware components, or by designing the processor in such a way that whenever the no operation is carried out by the processor, it should immediately go into the sleep mode. That is the third characteristics. The fourth one is fast execution time. In real-time embedded system, certain tasks must be performed within a specific time. So in order to meet the performance constraint of a real-time system, a special operating system known as real-time operating system must run on this embedded system. So the next characteristic is efficient use of memory. Most of the embedded system, they contain only the RAM and ROM without any secondary storage. So for that purpose, the flash memory, it is used in order to store the program including the operating system. So next one is the processing power. Next characteristic, the processing power, it is defined as the number of instructions executed per second. So that you are going to call it as a processing power. So most of the processor will execute the instruction in one clock cycle. So these are the characteristics of an embedded. So next is an embedded microcontroller. So this diagram, it is a typical microcontroller system with embedded microcontroller. So when a complete hardware required, so in order to run a particular application, so whenever you want to run any particular application, so whatever the hardware you require, if that complete hardware, if it is available on the microcontroller chip, the complete hardware required in order to run a particular application, if that complete hardware, if it is available on the microcontroller chip, then you are going to call the microcontroller as embedded microcontroller. Embedded microcontroller means, so whatever the hardware you require in order to run a particular application, if that hardware requirement, if it is completely available on the chip, then you are going to call that microcontroller chip as an embedded microcontroller. So this embedded microcontroller, it requires only the power, reset along with the clock. And this embedded microcontroller, they communicate with the external devices by using the digital I/O pins. So you have the parallel I/O pins along with the serial I/O pins. The parallel I/O pins are used to carry out the parallel communication. Serial I/O pins are used to carry out the serial communication. And you have the interrupt control pin along with the timer or counter control pin. So this is the embedded microcontroller. So next is the applications of the microcontroller. So this microcontroller, we are going to use this microcontroller in almost all the fields. The first application is at the home. So in our home, you are going to make use of this microcontroller in home appliances. Like you can consider the microwave oven, washing machine, fridge, and all those things. We are going to make use of this microcontroller. In the intercom, the telephones, cellular phones, video games, camera, toys, TVs, almost in all the electrical appliances, we are going to make use of this microcontroller. So second is in the field of the office. In the office, in telephone computers, in the microwave, in the printer, in the calculator, in the security system, fax machine. So in all those things, we are going to make use of this microcontroller. The third is in the military applications. The fourth one is in the field of automobile engine, in the flight control system, in the traffic light control system. In all those things, we are going to make use of this microcontroller. So microcontroller, it is almost used in all the appliances. In everyday day-to-day life, whatever the electronic equipments, what you are going to make use of, all those equipments, we are going to make use of this microcontroller. So which is designed in order to carry out some specific application. It's always the microcontroller, it's a small size device which is always designed to carry out some specific task, or which is designed to carry out some specific application.